So, hello and welcome to the Plutus IAS. Today we are going to discuss about the important topic of geography and which is jet stream, right? So, jet stream will be discussed today. This is about jet stream. So, first of all, we should know what the jet stream is. See, jet stream is upper tropospheric wind, right? Upper tropospheric wind. What the upper tropospheric wind? See, this is the surface, first layer of atmosphere, second layer of atmosphere. So, first layer of atmosphere is known as troposphere. So, in upper part, such kind of high speed winds are found known as upper tropospheric wind, right? With speed between 120 kilometer per hour to 230 kilometer per hour. So, high speed wind is there. This is geostropic in nature. That is movement in the direction of movement of earth east to west. Earth is rotating from what you say east, like that. This is the east, then east to west, like this. So, on the same way, jet stream is also moving, hence known as geostropic. Geo अर्थ, स्ट्रॉपिक स्टैटिक, जियो के साथ स्टैटिक है, जैसे जियो स्टेशनरी कहते हैं ना, उसी तरह से ये जियोस्ट्रॉपिक है. सो दिस इज अबाउट द जेट स्ट्रीम विच हैज गॉट upper tropospheric presence, then with high speed and geostropic in nature. Now we will discuss about the origin. Origin of jet stream. How jet stream is being originated, right? So this is about our globe, and this is equator. Above to that is 30 degree or more or less between 20 to 30, Tropic of Cancer, then Tropic of Capricorn, then you have Arctic Circle, then Antarctic Circle, and then Polar Circle or pole. While Earth is revoluting around the Sun, there is relative appearance of Sun over the surface of Earth. Sometimes Sun is appearing over the equator, causing directly incidence of temperature over the equator, which results into high temperature to that region, and river and water bodies of that region is more evaporating. As a result of that, air is getting uplifted, and then at the higher reaches of troposphere, it is getting subdivided, and it is supposed to be reaching to the 30 degree latitude and then subsides. Where it is subsiding, again divided into two parts, and one part is moving towards the pole, another one is moving towards the equator in the form of trade wind, right? On the same way, here in southern latitude, see the branch which is subdivided into the southern latitudinal region will ultimately cool down and subsides over the 30-degree latitude and then again diverge into the equator region and polar region. This is the story of the region with development of low pressure, because here in that region, say because of the high temperature, air is getting uplifted. So at the surface, low pressure region would be creating, and where air subside, high pressure region develops, right? On the same way in polar region, where temperature is already very low, high pressure region is created. And comparatively in lower latitude between say 50 to 60 degree, it is found that here temperature is comparatively more, hence low pressure is developed. Because of that low pressure, from this high pressure region where winds are accumulated has got the tendency to be moving. When it reaches to the low pressure region where some kind of air coming from this high pressure region of subtropic meets in the region of subpolar. This is the region of subpolar in nature. What happens? See, this is carrying more humidity and warm in their nature. Hence, when it comes closer, this humid air is getting uplifted in comparison to this dry and see cold air. When it comes upward, see reaches to upper troposphere, again it is subdivided into two parts. One part enters into the branch of subtropic where it is again subsiding. Another one branch is ultimately see subsided at the polar region. As a result of that, such circular movements are developing known as different cells. This is your Hadley cell, this is your Ferrel cell, and this one is polar cell, right? Ultimately, from equator region of low pressure and say respective high pressure of upper troposphere and high pressure at the surface of polar region and low pressure region of the troposphere, there is development of some kind of gradient. यहाँ से क्या होता है कि ये वाला जो एटमॉस्फेयर है, ये जो सेल है, इसका हाइट जो है वो थोड़ा ज़्यादा होता है, देखना है, ये हाइट ज़्यादा होता है. And the height of this cell, which is ferrule in their name, and this one is polar one, has got comparatively less height. तो ये वाला का हाइट ज़्यादा है, ये वाला का हाइट ज़्यादा है, उससे कम ये है, उससे कम ये है. So naturally there is some kind of gradient. यहाँ से क्या हो रहा है, इधर की तरफ एक ढलान बन रहा है, that is called as gradient. ये यहाँ समझ सकते हो कि there is development of some kind of slope. यहाँ से क्या हो रहा है, एक स्लोप बन रहा है, ऐसे करके एक स्लोप बन रहा है, इधर ज़्यादा ऊंचा है और इधर कम ऊंचा है, देख रहे हो ऐसे. उसी तरह से यहाँ भी पोल की तरफ एक स्लोप बन रहा है. यहाँ पर इस स्लोप पर कोई चीज को इफ वी आर pouring the water over this slope, it has got the tendency, it will be having the tendency to be moving towards the polar region. On the same way यहाँ पर पानी अगर डालोगे तो क्या होगा, ये मूव करके पोलर रीजन में होगा, आएगा. On the same way the air of the upper troposphere with the development of pressure gradient, because at the surface of equatorial region there is low pressure and at the surface of see higher reaches of troposphere there is high pressure. On the same way low pressure region is there present in polar region of say tropospheric height. So the gradient is already there and slope is also developed. Hence the air accumulated in the tropical equatorial region will have the tendency to be moving towards the pole, right, moving towards the pole. And at the same time there is impact of rotation of the earth, ये अर्थ भी रोटेट कर रहा है, इसलिए ये जो विंड यहां से इधर की तरफ चला उस पर, इस जंक्शन पर, वेयर देयर इज मीटिंग ऑफ, एक एयर ऐसे जा रहा है, ऐसे ऐसे, और यहाँ एक एयर ऐसे आ रहा है तो मीट कर रहा है इस पॉइंट पर, और यहाँ देखो कि एक एयर जो है वो इस तरह से आया, ऊपर उठ गया, और एक जो है वो इधर से आया, यहाँ पर उठने का टेंडेंसी है, और ये सब डिवाइड हुआ, एक ऐसे गया और एक ऐसे गया। तो इस जंक्शन पे और इस जंक्शन पे डबल सर्किल है। यहाँ पर क्या होगा, सर्टेन पार्सल ऑफ एयर will have the tendency to be tilted, to be shifted towards the rotation of the earth। क्या बताया कि यहाँ पर क्या होता है, at the junction of Ferrel cell and Hadley cell, certain parcel of air, because of the high speed wind moving from equatorial high reaches to the polar high reaches, see certain parcel of wind is shifted towards the rotational direction of the earth। This is the earth moving like this, है ना, ये अर्थ है, इसके चारों ओर एयर भी है। अब क्या हो रहा है कि इक्वेटर रीजन से पोलर रीजन पे ऐसे स्लोप है, ठीक, और अर्थ भी ऐसे घूम रहा है, तो क्या होगा, इस स्लोप पर सर्टेन पार्सल ऑफ विंड विल बी मूविंग टुवर्ड्स द रोटेशन ऑफ द अर्थ। ये रोटेशन ऑफ अर्थ ऐसे है, तो सर्टेन पार्सल ऑफ एयर जो है वो अर्थ के रोटेशन के डायरेक्शन में ऐसे मूव कर जाता है, दैट इज कॉल्ड एज जेट स्ट्रीम। सो व्हाट वी टॉट हियर इन कंक्लूजन, दैट jet stream is upper tropospheric wind since it is originated in upper troposphere. High speed wind because all the winds of upper part of the atmosphere is high speed in nature, since all the air is becoming friction free in the upper troposphere, hence the wind would be already high speed, or their speed would be comparatively more. And then see, this is tropospheric, so this is what you say geostrophic, because see the movement or the direction of movement of this wind is in the direction of rotation of the earth. So this is geostrophic one, this is geostrophic one with speed between this one to this one, high speed wind is there, and then upper tropospheric wind. This is all about the jet stream. So today we have discussed about the basic concept of jet stream. Thereafter, impact of jet stream, how it is impacting over the climate will be discussed in later part. Thank you.